very quickly. He says, he lies, but I've got a moment. So this is a part 2 to my other previous episode on Mexican waves at the MCG. I went to sit down with Cam a little earlier, about an hour and a half ago, because I was all excited about these Mexican waves at the MCG. But I moved on from there when I was chatting about Mexican waves at the MCG. I moved on from that, because I said, now I'm imagining an electron going around the MCG rather than a Mexican wave going around the MCG, and I went on from there, But back to the Mexican waves, I sat down and, Cam, I'm all excited about Mexican waves. He looked at me the way he does, and he said, one of your socks is odd. And it was. Because I was wearing one white one and one black one. I grab whatever I can. Which one was odd, And that's a little bit quantum in and of itself, isn't it? You got a choice there. Which one's odd? Which one's right? All right, and which one's left? All right then. So, I wanted to talk to Cam about, I wanted to move on from the Mexican wave, sort of thing, and get on to stuff I've been thinking about, freaky stuff. Not just thinking about it, I've been listening about it on podcasts about quantum physics and all that, quantum mechanics and all that sort of stuff. But he got me stuck on the Mexican waves because he got excited about the Mexican wave. He got me distracted about the Mexican waves. And we ended up talking about, and that's not what I want to talk about here, but as it turns out, we ended up talking about, you can start 2 Mexican waves at once at the MCG or any ground. And if you do, suddenly we started thinking about, we've never been the guys that, the lucky guys that are exactly opposite to where the Mexican wave started, on the other side of the ground, because that's when the 2 waves meet. And that'd be exciting, because you could see one wave coming and the other wave coming towards you. You say, I think I'm the guy. I think it's got to meet at me. And I bet you, if I did that, I'd get extra excited. And this is what Cam and I were sort of talking about. If you were that guy, or one of the guys in the line of guys in Bay 24, where the Mexican waves meet, the 2 Mexican waves, one going the other way and one going that way, it'd be very exciting, and you'd probably do an extra big wave and you'd yell a bit louder, hey, I'm the guy, and you'd probably throw your footy record up in the air, and to a certain extent, you'd be kind of being like a water wave, because water waves, when they come together, 2 small water waves, we're not talking breakers, but 2 small water waves come towards each other. When they meet, it's twice as big. I wonder if you could do it. You could do this as a test. This is what Cam and I were talking about. You could do this as a test. I wonder if at the footy, if you've got your little measuring devices out, and your lasers, and if when 2 Mexican waves, because most people go, yay, but just normal, but maybe the wave is twice as big where it meets. Yeah. And then we got talking about all sorts of things to do with the Mexican waves. Whether, that line, because you got Mexican wave, and another Mexican wave going the other way, and there's 2 lines of people. There's one at that side, over that side of the ground on that wing, and there's one on this side of the ground on this wing, and that's where the 2 waves meet. So they meet twice per circumference, and what were we wondering about that? Well, there's another experiment you could do. You could test whether humans, whether the 2 waves go at the same speed, Or is there a kind of bias with humans? Is there a kind of bias with humans where going to the left, do people do that faster than going to the right? And do the two waves go a little bit? If they did, that line of people would slowly move. You know, the node, you know, or the people at the interference point where the two waves interfere, that would move. It wouldn't be the same guy every time. You know, let's say my name's Roger, and I get to do the big wave because the two waves met at me. But it might be next time the two waves go around, Mary might be the guy. Mary next to me, and I miss out. Hey, I was the guy last time, now you are. And then maybe it'll wander back to me again, and I'd be the guy. But maybe if there is a bias, maybe that line, it's not this wave, you know, the wave's going around, it's a much slower wave. It's the wave that line is, and it might take a year for that line to get right around the ground. The Mexican wave takes maybe a minute, the normal Mexican wave. So you've got a wave within a wave. Yeah. That's not what I was going to talk about. What I was going to talk about is, in my previous episode on this YouTube thing, I was imagining, you know, how does an electron work, you know? How does matter work? How does a brick work, you know? And the way that works, and the only way I could imagine it, and this is why I got excited about Mexican waves, is I was imagining a Mexican wave going around and around, and another Mexican wave going the other way around and around and around, and I was imagining that it was only one line of people. Let's say the sixth row. You know, there's only enough people in the ground to actually just fill one seat, one row of seats all the way around the ground, and all the rest of the stands are empty, and the first 5 rows are empty, but the 6th row is packed full of people, just one line of people. And you start a Mexican wave going with just you know, that row of people right around the ground, and they can do a very successful Mexican wave with just one row of people. And I was imagine that 2 waves going around, and then I was trying to think, now how does an electron work, you know, in a particle accelerator, you know, because that's circular too, you know. And I was just imagining that in my previous episode, and I was saying, all right, well, that would be a bit like if the Mexican waves are going around, you can see them. You can be standing, you could be the other guy way up in the stands. One guy up in the stands, that's me. And I'm looking, and what if I kind of looked away? I didn't do this in the last episode. What if I looked away? And then while I was looking away, watching my phone, doing a YouTube episode, watching my phone, but I took my attention away from these 2 Mexican waves going around and around and around, and I looked away, and then someone rang me and said, are you looking at that Mexican wave still? See, this is a better way to put it. And I said, no, I'm not, actually. I got distracted. I got bored, actually, watching the Mexican wave go round and round and round and round. I got bored. And they say, well, here's a funny thing. Now, don't look, they say. Don't look. You wouldn't believe this, though. I'll just tell you this is the case. I'm outside the ground. This is your mate is ringing. I'm outside the ground, and all those people you had in there doing that Mexican wave, you know, they've come out. They're not in there with you anymore. I say, you're kidding. And he said, don't look, though. Don't look. But they've all come out. And he said, but I've got something else to tell you. They told me that even though they left the ground, they left the Mexican wave still going. At which point, you know, I would say, how can that be? Because the Mexican wave depends on people putting their hands up and down. A little bit like a water wave. Depends on people. It depends on water molecules going up and down. That's how the wave moves, you know. That's what I'd be saying. I'd be on the phone to my mate and I'd say, there's no way that the Mexican wave is still happening if all the people have left. They're not in row 6 anymore, waving, you know, the big cheer every time the 2 waves me. He said, no, it's still going. And I said, what? And he says, not really, but what is still going is there's 2 electrons going around there now, and electrons can do what those people were doing as a Mexican wave. The electrons can do that same thing. They're a wave. They're moving around like a wave too. I said, what do you mean moving around like a wave? Well, I'll get to that, he said. But the funny thing is, he says, what those people were doing, there's 2 electrons now going around. The MCG, nice and fast. We actually installed a tube while you weren't watching, and there's a big tube around. There's 2 electrons in that tube. One's going one way, one's going the other way. We call it the Small Hadron Collider. And I said, oh, that's very interesting. I didn't hear you installing all that. I must have been sitting here for a while. All right. But anyway, he said, yeah, it's happening. I said, oh, that's very interesting. So there's a wave going around, but there's no one causing the wave. You know, there's no one doing this. So he said, no, it's a very special kind of wave. It's a wave that's going around, but it's not waving in anything. It is the wave. So it's like, he said, a Mexican wave. It's like a Mexican wave going around, but the Mexican wave that you saw before depended on someone waving up and down. You know, same as like in a wave in the ocean depends on the water going up and down, or a sound wave in air depends on the air molecules sort of vibrating backwards and forwards. But he said this electron and the other electron that are going around the MCG now, right now, down below, don't look, he says, but I'm just telling you, it's a transparent tube, and we've got the electrons going around there. And I said, oh, right, that's very interesting. And he said, but they're not actually, there's a vacuum inside the tube. There's nothing in there waving or doing this or doing that or doing anything. The electrons themselves are the waves. So it's like a Mexican wave going around without the people doing that. Can you imagine all the people walking out of the MCG, he said? Can you imagine them all walking out, the Mexican wave still going? And I said, no, I can't, because, you know, I've only ever seen Mexican waves with people doing that. And he says, well, that's what's happening. You've got 2 electrons going around there. And I said, I might go and have a look at those guys and see, because, you know, that looks really interesting. That sounds really interesting to have a look at that. And he said, don't look. And I said, all right, I won't look. Gee, well, why are you saying that all the time? He said, because the funny thing is, he says, and now this is only my limited understanding of quantum physics I'm about to say here. I'm not trying to be a clever clogs. He says, the funny thing about that is, as you sit there, what the electrons are doing, they're not actually running around like, you know, 2 little ping pong balls in a tube. What they've done, they're both those electrons, right at this moment in time, they've actually set up a bit of a wave pattern in those tubes. And I said, where are they exactly in the tubes at any given time? He said, everywhere. Both of them are everywhere. But I said, hang on, I thought you said that one was going around that way and the other one was going around the other. They are, he said. But they're also, they're not, they kind of are, but they're also, see, they're a particle, you know, they're a ping pong ball and they're a wave at the same time, because they're not like the Mexican wave. I said, you're not explaining yourself really well. He says, I know, but look, just take it from me. Why should I? Yeah, he says, just take it from me because I'm smarter than you. And he said, those 2 electrons, what they've actually done is set up a little bit of a wave pattern, you know, like a standing wave pattern. you know, a little bit like electrons do in an atom. He said, if you're not looking at an electron in an atom, the electron has set up a bit of a wave pattern inside all the electrons in an atom. They aren't anywhere specifically in the wave. They've set up a pattern, a standing wave pattern. You know, like when you see, when you see a spring or a string on a guitar vibrating, brrr, like that. But if you look closely, it looks like it's solid. You know, it's got that shape, and it looks like it's in all the spots at once. But it only looks like that if you look closer. You can see that it's moving up and down the string. But you go brrr, like that, and it goes. Rrr. He said the way the guitar string looks like it's doing that, the electron is doing that. It's set up. It has set up a wave pattern all through the tube, all the way around. It's in all the different sort of spots in the tube at once, and so is the other electron, and they're both sitting there like a standing wave pattern. I said, that's weird. He said, yeah. It is, isn't it? He says, I'm not sure that's even true. He said, I know if there's one electron, that would be the case. What if there's two electrons? They're kind of coming into contact. The two standing waves are coming into contact with each other. There's a word for that. Those two electrons have become entangled. And he said, well, because they can sort of interfere with each other. He said, you know what? Even that is a standing wave pattern, but it's a more complicated one between two electrons, you know, and they do interfere with each other catastrophically sometimes, I think, but we'll get back to that. And when they do catastrophically interfere, I think suddenly, you know, because they've come into contact with each other, they are suddenly presenting to each other as particles, even though they're kind of waves and they're particles at the same time. And this is where it gets really confusing. I said, oh, look, I've had enough of this. I'm going to have a look. And so I have a look from up in the top of the stands, and I look down at the tube, and let's say I've got amazing eyesight, such that I can see electrons. Let's make it two ping pong balls going around, sort of really fast. Doesn't matter if it's an electron or a ping pong ball. But I've got amazing eyesight, and I can see the wave pattern that the ping pong balls have set up. And the wave, and let's say I've got amazing super eyesight. You can't technically see an electron, because an electron, the act of seeing it, makes no sense, because the wavelength of the electron is about the wavelength of a photon of light. You can't do it. But let's say I'm what some physicists in the old days used to say is a kind of demon, you know, a supernatural demon, and I can see the wave patterns, or I can see the electrons at least. All right, when I look down at that tube with the electrons going around, the wave pattern that they had established was, you know, in a very real sense, it was a wave, but it was a wave pattern, and it wasn't even either. There's more chance that it could be in one spot than another, each electron. You know, it's more in that spot than it is. It's everywhere, but it's more in that spot than it is in that spot, and so on and so forth. But when you look at it, now I don't know if this is right, but apparently there's some freaky stuff going on then. When I look at it, I'm part of the game too now. The two electrons are interfering with each other, but me as a wave form myself, because I'm just like the electrons, or if they were ping pong balls, I've got a wavelength, you know. It gets really weird, but the act of me engaging or entangling myself with the electrons simply by looking at them causes them to have a great big fright of some sort and shrink into a certain spot and become a real, and turn into a particle. They give away their wave-like look and feel, and suddenly they're particles. Just what happened before is there was a probability that they were anywhere, sort of thing. And when I look, all the probabilities disappeared. A little bit like in the middle of a footy game, there's a probability that one team will win or the other one will win. So when I'm watching the footy, I don't know who's the winner, you know, but once the game finishes, I do. So the probabilities collapse, you know, everything collapses. And that sort of happens with the electrons. My God, it gets weird, you know. That's the stuff I was going to talk about to Cam, but I didn't make it. And because he got sidetracked on the Mexican wave stuff, and then I had to go. I'm only about a millionth of the way through, sort of trying to untangle this whole business of quantum physics. It's very confusing and very amazing and very weird. But then, you know, to young people who grow up with all this stuff, which I didn't. Maybe it's second nature to a lot of young physicists in universities these days, and they think just the idea of when they look around, they probably, people who are really into quantum physics and spend most of their time thinking about the quantum nature of the universe, how everything's a wave, but then it collapses into sort of physical objects, you know, as soon as you come into contact with them and all that sort of stuff, because stuff is waves and stuff, but at the same time that same stuff is particles when we're talking matter. And I'll bet you there's some people in the world who look around and they say, just the fact that everything looks like that building there looks like a building, and this car looks like a car, and they look at their own hand and they say, I know this is a wave, but I know it's physical too, and when I click, you know, that's two solid things making that noise, and yet I know those two things are waves, and if I look really closely, that's not even a hand, that's actually atoms and subatomic, that's actually subatomic, that's quarks and electrons and stuff like that I'm looking at, arranged in a pattern. This is not actually a physical hand, this is a pattern, this is atoms arranged in the pattern of a hand. I'm a pattern, and this car is a pattern, and that building's a pattern. I bet you some people actually think like that and get all freaky in their heads, and they think that the quantum stuff that's happening, because they're so good at it or so used to it, they probably think that stuff's all right. I get that, they said, I understand that, that's normal, but now this stuff looks weird, what I'm looking at. Yeah, these are all patterns. Is it all just, am I looking at stuff that's just waves? And then they say, yeah, but no, yes, and no. You know, some people say, yeah, everything's just a wave, you know, but as far as I know, these people who are good at quantum physics, I'm not, they look at all this stuff, say, yeah, it's all waves, but it also, when two bricks come into contact with each other, they're waves, all right, but when they come into contact with each other, they become entangled, what we would call smash. They smash into each other, but they come into contact with each other, they become entangled. All the atoms in one brick become entangled with all the atoms in another brick, and when you throw those two bricks at each other, they smash into each other very catastrophically. So the person who's good at quantum physics would probably say, ooh, okay, those two bricks were a wave before they were aware of each other's existence. You know, they were both flying through space, let's say, just totally unaware of each other's existence. Then suddenly they come into contact with each other and smash, bits of brick flying off everywhere, you know, because they were actually going really fast, and they just smash into brick dust, you know, because they were just going so fast, and they had a head-on collision, and that's a very catastrophic kind of collision. So and I'd say to myself, all right, they are waves, but when they come together, they don't pass through each other like a not too big water wave or a sound wave, or a Mexican wave might pass another water wave or sound wave or Mexican wave. When a Mexican wave goes one way and the other way, and the two Mexican waves cross each other, there's no catastrophe there. They go right through each other, and keep going. But these two bricks didn't do that. So you can't call them a wave the way that a Mexican wave is a wave. They're not a wave like that. You can't call them a wave like that. So you can't get all hippie and new age about them too much, because they did smash into each other, and very catastrophic. And you have to give a word to that. You can, all right, by all means, call them waves. And even after they smash, yes, all right, the whole pattern, all the brick dust and everything, that's still a wave in space of some sort. But you can't get around the fact that they did collide with huge violence. And if you want to describe that, you have to give it a word. And you would say, well, the reason it was so violent, even though they're a wave, the reason it was so violent is because when they came together, they displayed behaviour that I have to give a word to. What word will I give it to? They displayed the behaviour of something, and you just make up a word and you say, I'll just call that word, what happened there, as two solids meeting. People say, oh, they're not solids. No, they are by definition, you see, because I said I had to give it a word. You told me to give it a word. I gave it a word. So two solids did meet each other. It's not an illusion or anything like that. It's just a word applied to what happened there. So they are, they took on a solid kind of behaviour at that point in time. Yeah, you can say that in reality they are two solid bricks by definition, because that's the word I gave it. But they are waves as well. It gets very weird. That's I've got a long way to go myself. I'm just getting my head around this stuff.